Hey there, and welcome back to the Deep Dive.
Glad to be here.
Sometimes the most powerful tools, they aren't brand new tech, right?
Uh-huh.
They're classic ideas used in, well, fresh ways.
Absolutely. And the source material we looked at for today really highlights that.
It does. We found this great connection between a core math concept and understanding what's happening right under our feet.
Yeah, looking through those sources, it's calculus, specifically integration,
Integration, okay.
and how it's used for analyzing, real sensor data.
Right. And this is where it gets really interesting. The core idea is using integration, like as the main tool to look at sensor data. And the specific application they zeroed in on, understanding long-term patterns in soil moisture.
Exactly that. Soil moisture thing, but you have sensors, right? They give you these little snapshots.
Yeah, like maybe you're reading every hour or every day.
Right, just individual points.
Right.
But if you want to really grasp something vital, like how much water is actually in the soil over time.
Just right now.
Not just now, but the overall trend, weeks, months, you need more than just those dots on a graph.
Okay, so that's our mission for this deep dive then.
Yeah.
To figure out why integration is the specific tool the sources mentioned for this job. How does it take all those, separate little sensor readings and weave them into the bigger story, the long-term soil moisture story?
Well, the material spells it out pretty clearly. It says integration is used precisely to analyze this kind of data for those long-term patterns.
But why integration specifically?
Because, well, at its core, integration is really about accumulation, summing things up.
Okay.
It's the mathematical way you calculate the total change or the total amount of something over a period.
Right. Like finding the total distance you drove if you know your speed at every single moment. You're adding up those speeds over the whole trip.
Exactly. So apply that same idea to soil moisture.
Okay, I see. So the sensor gives you the moisture level at one instant.
But integration lets you figure out things like the total water plants used over a week, or maybe the cumulative loss from evaporation during a dry patch.
Okay.
It helps you see the net effect, the overall balance of water across a whole season, maybe?
That makes it really concrete. So instead of just seeing a line going up and down with daily readings,
Yeah.
integration lets you actually calculate, say, the total water deficit that built up during a drought.
Or the total gain from a few days of rain.
It pulls together those single points to give you a number or maybe just a clearer trend that shows the long-term impact.
Exactly. It bridges that gap, between the continuous natural process and the discrete data points we actually collect with sensors.
So even though the sensor reading itself is just a point in time?
Right. The mathematical methods, often it's numerical integration we're talking about, they let us approximate that continuous summing up process from the discrete data.
Okay, so it's not just abstract math theory. It's adapting integration for the kind of digital data we actually get. That makes a lot of sense.
It does.
So the real value here is huge. Taking raw, maybe messy sensor data and using integration to pull out this really practical long-term understanding of something as vital as soil moisture.
And think about why you, the listener, might care about those long-term water patterns in the ground.
Yeah.
I mean, if you're a farmer managing irrigation or city planners thinking about stormwater,
It's also critical.
ecologists studying how ecosystems function, understanding those trends is absolutely fundamental. This isn't just like classroom math.
No, it's essential environmental intelligence.
Exactly.
So this deep dive really shows how a classic tool, integration, steps out of the textbook. It becomes this powerful lens for seeing the cumulative story.
Yeah, how water actually behaves in the soil over longer stretches of time.
All derived from standard sensor data that's being collected all over the place.
It really lets us step back from the hourly wiggles and see the bigger picture, the trends, the totals, the things that really matter for managing water, for plant life, for the environment's health.
It really does make you wonder, though, if applying integration unlocks such key long-term insights from soil sensors, what other complex environmental data sets are just sitting there? Maybe like air quality records over decades or glacier melt rates.
Yeah, waiting for the right mathematical tool.
Exactly. Waiting for something else from that calculus toolbox to come along and reveal their long-term secrets. What else can we understand?